Oh, does it mean, is that like it can be
It,
used in many languages?
no. It's defined as in design. It's defined in a programming language.
Oh, I've gone live on YouTube, guys. It's not unlisted, this one, so you'll be able to see it. So it's just gone live. I'm saying if you like, I'm wondering whether you watch it on YouTube but have it on mute, and that way you can get the audio of YouTube, get the video of YouTube, and not have to worry about like finicky audio. I'll get the. Hang about. It says I've gone live, but then I can't see. Oh, now it's not saying anything. Oh no, it is there. Right. Well, how the hell do I get that? Do you know this other one? It works so much easier. Oh, there it is. If you go to my channel, it's right there. Actually, it just says he's gone live. We'll see if we've got.
Oh yes. Oh yeah. It says in my subscriptions.
Yes. Well, if you go to, but let me see if I can actually get the link. It's just because it will be easier for you guys to actually see it. Doing that.
It started streaming 69 seconds ago. That number get me in a lot of trouble once.
Yeah, it will do. There you go. Link's there if you need it. Anyway, sorry. So, abstract data type. What do we get to? What is an abstract data type?
Would you say it uses operations?
So it
No,
uses operations. Yeah, I agree with that. What we're talking about, right?
It's logical description of how the data is viewed in the programming language.
Well, what we're talking about is this, okay? So if we've got an abstract data type, we're saying that... do you remember the definition of abstraction was that it allows us to hide complexity? Remember that? So the idea is that it removes unnecessary complexity, allowing you to focus on what's important. So the deal here is that actually to do a stack, there's going to be some kind of, in the center of how a stack works, there'll be the physical slash logical operations to make the actual stack work. Now, we said that a stack could be embedded in one of two things. What could the stack be embedded in?
It could be like embedded into like...
Into what? What were the two things could it be embedded into?
It can be embedded as a queue, stack, trees, and graphs.
I'm saying a stack and a queue, which we talked about, are both abstract data types. They could be put inside something else. What else could they be put inside?
Array?
Yeah, an array, which is an example of a...
Abstract data type.
Nope.
Data structure.
Static.
Static data structure. Or it could be placed inside a
Tuple.
A list, which could be a static data structure. The point being is that at this level, the logic here, that's going to be your actual array doing the stuff that you want the queue to do. And then outside that, you've got your abstraction layer. So this layer is abstraction. So this is going to provide, operations. What kind of operations do you have for a stack? We were looking at it. I left it there for the first slide. What was the operations?
Push. Pop.
So we've got pop.
Hey, YouTube's down.
We've got push. Anything else?
You got push. You can check if it's full. You can check it.
Check full. Right.
Oh, remove.
Check if it's empty.
Now,
and
the whole point,
assign one.
This is all good, right? So there'll be a bunch of functions. And abstraction, do you worry about what's happening here physically at the array level?
Yes.
No.
No, that's hidden away from you. What do you focus on?
That
Just the
operations.
Yeah, these methods here. So these methods here are what allow you to make use of the stack. And that's the idea of abstraction. Imagine every single time you wanted to go and use a stack, you had to implement it yourself and create all the structure yourself. So the point is that it allows you to hide that complexity away from you. So you can, remember, we've only got quite small working memory really. So we don't have to thinking about how it actually works. You just worry about, oh, push does this, pop does this, check size does this. like when you've used in Java, what kind of, I'm trying to think, you've used scanner class to input data, right? So it's like scanner input equals new scanner.system.in or whatever, and then you go input dot next, allows you to take in a string as a bit of data. Understand that's using abstraction as well, and there might seem like there's a lot going on, but actually, when you go dot input, there are lines after lines after lines of things that are actually happening. So that's what abstracted data type really means, is that you can focus on these methods and not focus on what's happening, the physical and logical operations to achieve those things. Same with a queue. You only focus on the methods. You don't focus what's going on here. Same with a linked list. But what I thought would be fun for us to do today, that might be fun in inverted commas, is that we could have a look at implementing on here. Where were we? No. These, right? These functions here. Let's actually look at what's happening. Let's do the logical operations ourselves. Now, we haven't learned, unfortunately, about what haven't we learned about? We've not learned about classes. So we're going to have to do this just by doing subroutines. But we need to see that we can implement. Let's not worry about peak and size then. Let's just worry about push, pop, is full, and is empty. Now, what were the two things we said we could implement a stack inside?
Arrays.
Arrays and
List.
lists. Do you know how to create a list in Java?
Do you use like square brackets?
Do you know how to create a list in Java?
Yeah.
No,
No.
not really. No.
There's something called an array list. And
I
an
think
array
you have
list
to-
works like a list, but I've not taught you how to do that. But what do you know how to do? You know how to use an
Array.
array. So guess what we're going to put ours inside? We're going to put it inside an array. What are the four things that array needs in terms of its definitions? It needs...
It needs to be static or dynamic or static. It needs a class. You need the size.
No,
you need a data type.
An
you need
array-
a data type.
An array... Are there static arrays and dynamic arrays?
Yes.
No.
No. An
Only
array
static.
is always static. What does static mean, Zahid?
It means you cannot change it when the program is running.
Change
It's
what?
not.
You said
You
change
can't
it.
change. You can't change the size of it. You can't change anything. You can't change anything in your array.
You can change the things in, because be very careful with these definitions, Zahid, because then what you're saying then, you can't change anything in the array. That gives the impression you couldn't change the data inside the array. Can you change the data inside the array?
Yes, when it's not running.
When it's running, can you change the data inside the array?
No.
So I'm going to create an array. The four things, by the way: data type, size, dimensions, identifier. Let's say that mine's going to store, gosh, what should we make it store? How about strings? We could store names, couldn't it? We could stick names on it. So we've got string, one-dimensional, names equals new string, and they'll say it's 10 in size. Okay. What you're saying is then when the program's running, could I change what's held in 4 to be Bob whilst the program's running?
No.
Who agrees with Zahid that you can't change what's held inside the array?
Oh yes, you can. You can change it.
So, what are the things you can't change? To be a static data structure, it's not changing the data. What are the things that you can change?
The size.
The size.
Yeah, you can't change the size of the array once it's declared. Once the program's running. Anything else?
And the data type, you can't change it. The
I
data
suppose
type.
that's true. Yeah, that is in the nature of an array, though, that it keeps it. But that's not really static. So don't forget about the data type. What was the other thing? Size and
Dimensions.
dimensions. There you go. Those are the two things that are fixed. And mainly we're worried about size in this context. So once I've declared it as being size 10, which I have here, I can't make it a different size without breaking the array and establishing a new one. That's what makes it static data structure. Anyway, let's have a look. You can see, or can you see? In fact, let me swap these over so that you can see. Nope, nope, yes. So hopefully over here you can see that we've got these functions down here. We need to implement them. So we've got push. Oh, I won't do it inside here. I'll need to go over here. In fact, if I'm creating multiple subroutines that are all accessing the same array, right? So I've got this one, I've got push. I'm going to want to do, don't worry about the syntax for a moment. The syntax is all going to be broken until we get there. In fact, let's just worry about doing two things at the moment, pushing an item on and popping it off. If I want, both of these are going to access this array. If they're both accessing the same array, do I have to make this, should this array stay as local or should it be global?
Local.
So if it's local, can this one, so if I say push, and I'll say, what's the data types that are being pushed onto the string? Onto the
No,
array.
it needs to be global so other subroutines can access it.
There you go. So we're going to want that subroutine. Well, there are two choices. Choice number one is you declare it as local and then pass it as a parameter. So here it could receive the array. So it could receive the string array and then use it, which is actually the better way of doing it. But we're going to cut some corners so that we can get the understanding in. So I've made that global now. Unfortunately, this is something about this is something that we're going to need to learn about at a later point, is how to create classes. Now, currently, we don't know how to do that. And so because we're referencing this variable from a static context, we're going to have the phrase static attached to all of these. Now, I know we're using the term static to describe an array. Static in this context means something slightly different. Once we create an array, once you learn how to create classes, you can declare a class, instantiate an object from that class, and then nothing has to be static anymore. Unfortunately, we have to learn to walk before we can run, and I think we need to. So at the moment, just take my word for it that anything that this needs to reference will have to be static. So you see now you can actually access it directly, which also means that all the other subroutines will have to be static. Okay, now let's look at our first subroutine. I want to push the item. I want to push an item. Is that what are the two types of subroutines?
Push and pop.
So the two types of subroutines that you can have are push and pop. You're saying that because you're looking at push and pop right now, correct?
Yep.
I'm not saying what are the two types of subroutines that we have in our stack. I'm in our stack class. I'm saying what are the two types of subroutines in terms of when you can return or not return data.
Oh, hang on.
Procedure and function.
Right. There's procedure and function. So what are the differences between those two?
A function returns a value and a procedure doesn't return a value.
Thank you. I am perfect answer. A procedure doesn't return a value and a function does return a value. If I'm pushing a value onto a stack, which I'll be doing now, is that going to be a procedure or function?
Function.
So it's going to return a value. Why is it going to return a value, Zahin?
Because you're pushing the stack.
And then what will be returned?
And it would be returning a value.
So when you push an item onto the stack, you're also taking it off the stack at the same time.
Yes.
Does anybody agree with Zahin? Let's visualize what that's going to look like, what you're talking about. You're saying that essentially we've got this stack. Excuse me for my drawing skills. They are not what we call proficient. I've got a stack here, okay? And these are spaces on my stack. And then I'm going to push data onto the stack. Here's some data. In fact, why don't I do it the other way around? I'll do that. So we're going to push data onto the stack, and now the data is here, being held here. What was returned? What do I return from that? What data
You don't return anything.
So if I don't return anything, is it a
So it must
procedure?
be it's a procedure.
There you go. So it's a procedure in this case because I'm not returning a value. I'm just sending a value in this case. Now, in Java, the way that works is that you write the term void. Void means it's returning void. And what is void? Do you know what the term void means?
Nothing.
Yeah, nothing. Yeah, nothing. So that's how you indicate it's a procedure. Like I said, you have
invalid.
You have to say static because if you want it to reference from a static context, it has to be static. Like we'll get over that at some point. And public refers to visibility in object orientation. So, you know, that is something where we're going to have to learn about. It says I got bad quality all of a sudden. Do I have bad quality? It's saying I've got
Yes,
bad
you do.
quality on Teams, but on YouTube it's saying I'm uploading at 5 megabits. So,
I can sit fine.
yeah.
On Teams it's a bit buzzy, but YouTube is a lot clearer.
Yeah, I think it's basically these Microsoft servers are struggling. Anyway, where were we? So we're saying it's static because we're referencing from a static context. We're saying it's void. Why are we saying it's void? Because it's a
Procedure.
there you go. And then the name of the subroutine is push, and then we're saying we're pushing an item. What data type is my stack going to be?
A string.
There you go. So string item. Open brackets, close brackets. There we go. The red writing's disappeared because now we've actually formed it correctly. Okay. Now, let's come back to the idea. Have a little look now at my diagram. I'm saying I'm pushing onto this stack down here. How did I know it was going to end up here?
Because it's not only one.
Well, I need to... where's the next one going to go?
On top of it.
So it's going to go here. So imagine we've got index. So we've got, 0, 1, 2... What's wrong with me? 2, 3, 4, right? So this is our index going up here. We have something that identifies it. We said that the queue has 2 of these and the stack has 1 of these. What is it that it has?
Pointer.
Pointer. There we go. So we need to have a pointer which started off here, and as soon as we put it there, what happened to it? In fact, let me get a shape. Ooh, I'm gonna get fancy right now. Oh, right. Boom. Sorry, little things amuse me. So I got the pointer. It started here, right? And then, as soon as I put that one in here, it's going to go to the next place, right? Yes?
Yes.
Do I need to implement that?
Because we use the code.
Well, do I need to implement the idea of a pointer to identify where the next free position is?
Yes, you do.
Yep. So in here, as a global variable, I'll go static. What data type should it be?
It should be an integer.
Yes.
Because it's
Yep. I agree with you. And we'd initialize it as pointing at position.
position 0. Actually, index. Would you like to do index -1? Like,
Oh, what an idiot. What have I got missing out here? I honestly didn't see it for a second. What have I got missing?
you're missing. You need to do -1.
No, what am I missing here out of my phrase that's not happy with me? I honestly
The
can't believe I
2
just made that
inverted
mistake.
comma.
Huh?
The little commas. The little
Yeah, you need a square brackets.
No, square brackets is for an array. This is not an array. Honestly, I feel like I'm prize more
You need
right
a
now.
warm bracket.
You need to.
It's missing something. Something pretty crucial to declaring a variable. Yeah, I've got this data type. I also need to say something.
No, you need to get rid of static because you haven't declared the variable.
1 second. Will's just sent me a message. Thank you. The identifier. Spot on, Will. Although you spell like me, so... yes. So the pointer, yes? Yes? Yeah. It's obvious when you see it, right? So now what we're saying is when we're pushing it, right, now we're in the position here where it's received an item. Where are we going to push it onto?
Push onto the next available space.
So what's the name of our data structure that we're using?
A stack.
Nope, that is the type of data structure. What's inside here in our programming code? What was the name of our data structure? We're saying,
Array.
yeah,
Array.
it's an array. And what's the name of our array?
Names.
I want to get to a particular position on name. So how do I do that? What do I do to do that? Guys are leaving me hanging. If I want to access, I want to put it up at a position, I need to put something around it. Here's my clue.
Square brackets.
Square brackets, there you go.
Yeah. Yeah.
At what position do I put it? So I'm trying to push this onto the stack. Where do I put it? Now, you can remember, you can come back to here. What did I use? This is a little bit of a clue.
Identifier.
No. What
Pointer.
am I moving
Pointer.
around? The...
Positions.
Right. What am I moving around on my PowerPoint? The...
Pointer.
There you go. So names at position pointer, I'm going to put on item. Right? Now, come back to my PowerPoint. No, come back to my slide. No, I don't know what this is. Come back to my iPad, bottom right. See that? I've now placed this item on here. Where does the pointer have to move to?
That's going to move. That's going to the next available one.
Boom. So, and then pointer, you could say pointer plus plus, but I know some of you are used to using Python. So we'll go pointer equals pointer plus 1.
Mr. Foster, do you need to? Should we just declare another variable, another static variable called next available space on the stack?
Why?
So because it'd be more efficient if you like import
Why?
more. Why?
Yeah.
Well, to check it because you don't want to like overfill it and all that stuff.
Right. Now, what you're saying is when we push, because we've not done that, when we push an item, what is it we should always be checking for?
You should check it if it's full or not.
There you go. So, guess what, guys? That's how to push an item, and I'll check it out here. So I'm going to change it now, and I'm going to say push Bob. Now, what should that do?
That should push Bob.
So that's this one here. One gets put on. Push. Sorry. In fact, let me reset it. I've initialized. Oh, flip. I'm not going to erase this very easily. There you go. Oh, that is ugly. Right. I'm going to do this in a more sustainable way next time. In fact, here's how I'm going to do it sustainably. Check out the skills. Oh, that's a bit small. Oh, piece of junk. I'll make that bit... I'm sorry, guys. I'm sure it's not that much fun watching me struggle. I will get there, he says.
Mr. Foster, would you just
So,
do
there we
like
go. So,
push dot is empty close brackets?
so Bob is here. Yep, here's Bob. So here's my initialization. So I've got on this line up here at the top, I initialized a new string of size 10. Admittedly, this is not size 10, but imagine it was. Okay, I'd initialize the pointer at being a 0. So this pointer is now pointing at this position at 0. And then I've said push Bob. So I've gone names at position pointer. So here, take Bob. Bob goes in here and gets pushed onto the stack. What's the other thing that happens?
The pointer gets added 1.
Boom. And then I'll go push. It's always Bob. Push. What's the female
Gareth.
version of Bob? Bobina.
Gareth.
Gareth is not the female version of Bobina. Bobina. So here's Bobina. Bobina gets put onto the stack. Boom. And then the pointer will get moved up. right? So if I run this, I need to comment that out because it will crash the code. If I run this, you can't see it because it's at the bottom. You see what happened? Nothing whatsoever.
Nothing.
Yeah?
Because you haven't outputted it.
Yeah, indeed. So in the background,
It worked.
it's working. But so I might just put a quick. I'm gonna put another bit of code in here. I'll be like, which is just going to print out the contents of the array. Okay. So public static. Public static void print cont. I'm not going to return it. So it's a subroutine, and I'm not going to send it any values. And I'll just be like for int I equals 0. Oops, got my mic right in the way, which is not helpful. I less than. Assuming I've not made a mistake, let's run that. In fact, that's quite an ugly way of seeing it. Let's. Oh, but it'll do, won't it? Who cares? I was going to put it all in one line, but you can see that. Yeah. So Bob, Bobina. So is my stack working?
Yes.
Yeah.
Guess. It's not a very good guess. Guess what I want you guys to do. All right. This guessing game, okay. This guessing game's not going well. I want you to implement pop. Yes? And, yeah, let's just say pop. Because I was going to say implement full and... in fact, I'll write them in now, the other two, yes? I'm not saying that you need to do it right now, but it's a placeholder. And then there are other people who are going to do it faster. So we've got pop. So you need to implement pop. At some point, we'll have to do is full, and we'll have to do is empty. You guys need to implement pop. Do I think it's going to be super easy for you guys? Nope, but it's a nice little challenge. And who doesn't love challenges? So in NetBeans, you're going to have to open it up, go file new, well, I'd say new package, call it stack. You can copy that stuff there and then have a go at trying to implement pop. You will be struggling for a while, I get that, but the learning happens in the struggle. So I'm going to just replace me with, where was I? With another window. Who feels nervous about doing this? Nobody? Awesome. One second. I'm going to give you guys, what you reckon? I'm going to give you 15 minutes, which is enough time to, 20 minutes. Because then people who have finished, who have successfully done it, can go on to see if they can do full and empty. Because you need to copy it as well. In fact, you know what? This is me being decisive. I'll say 25 minutes. Right? And it'll give you enough time to have a real attempt at this. Because you have to copy that bit down first, obviously. Yes? So make a new program in NetBeans, a new application called stack. You can copy that stuff down there, and then you need to implement pop yourself. And then I'll come back in 25, and then we'll see how you get on. If you've nailed it, and you're getting way better than that, that's great. Is what you need to do in that situation. Then you can have a go at trying to do is full and empty. All clear, guys, what you need to do?
Indeed.
All right. Okay. Well, I will mute myself, and I wish you guys the best of luck in your endeavor.
Yo, sir, I'm late, sir.
Sorry, I've just realised, Shazabe, I've been talking into a microphone that's been off. uh, so right now, people are on a programming. We're on a programming session. We're trying to implement a stack. You know what you could do? I've got this. I've live streamed this on YouTube, so because it's just much better quality. So I can stick the link in here, Shazabe. You're going to want to open up NetBeans, and then people have still got another. Oh, that's not helpful. People have still got another 18 minutes to go anyway, so you could go on to that and try and follow along. Wicked. I'll update the register. We missed you.
Mr. Foster, I've completed it. To put pop on. So I've completed it. So do you want me to like, do like size and like that type of stuff?
Yo, sir, I haven't downloaded NetBeans. I'm trying to look for which one I'm trying to download.
Okay, guys. Last 50 seconds, and then we'll review how to do pop. How to do pop, and then we'll have a look at is full and is empty. I think that probably rounds it up. And then I'd probably set a little bit of work for you guys to do in the background is thinking about, okay, with this knowledge, how would you implement a queue data structure in a static context? But yeah, last 25 seconds. Okay, brilliant. Let's get rid of that. Right, welcome back, people. Okay, let's pick on somebody at random. Josh, how'd you get on with pop? I don't know, maybe you're watching me through YouTube. How'd you get on with pop? Excellent. Okay, James. Josh, you there, mate? Oh dear. You know what I'm going to do? I'm going to take my bit of code, put it into a Word document, and then stick it as an assignment, because I'm not 100% convinced how much not everyone's buying into this, and that is just not acceptable, guys, because if we fall behind on doing these things, they may be hard. In fact, I'll say they are hard, but we need to try, and we get it wrong, but we need to try, because remember, and you know how much you love this phrase, ever tried, ever failed, no matter, try again, fail better. The only way you can fail, truly fail, is by not trying. So I'm going to send this, I'm going to stick on your teams, I'm going to stick the assignment on, and then you'll be able to fill it out and put in your code. I will talk through how to do pop, but I'll need you to attempt the other ones.
Mr. Foster, can you check my pop solution?
Yeah, well, what I'm going to do, give me 1 sec. I'm going to stick on Teams in Year 12. I'm going to create a new assignment, but of essentially what I've got here, the Word doc, not PowerPoint, the coding base, and then you'll have that to fill out yourself, right? So that you'll be able to, so I'll be able to see what you guys have actually done, because I've put a bit too much faith in people, I think, probably by just saying, get on with it in your own time, and then we'll check it. Being that the first person I've checked is not replying, I think is probably not even listening. Students edit their own copy. Stack Java code. A rubric. Attach. Okay. It'll take a little while to populate, but what's going to happen is that you guys will get this Java code thing sent out to you, and then what I'll do is I'll ask you to write your code in there, and then I'll review it, and I'll see how you guys did. So first of all, let's take the time. What's just happened here? Oh, there you go. The assignment's out, I think, because it's just gone, it's posted in Year 12, which probably means that you've actually got that now. So you can view the assignment. I'm going to talk through with you guys how to do pop. And then I'm going to ask you guys to, get all push and pop onto there, but also do is full, is empty yourselves. Right, so Josh isn't here. James is here because his mic's broke, which is totally fine. I understand that. If you could work on getting a mic, that'd be awesome, though, James. Because I must say, I don't know about you, I really enjoy it when we have this back and forth. Mo, are you there? In fact, I want people who are here to type something in. So, Mo, Will, Shazab, Zaheen. So Mo's here. Will, you here? Shazab, you here? Zaheen, you here? Karas, you here? Ian, you here? Can you please just type something or say something?
Hi, sir.
Thank you, Shazab. Yeah, brilliant. Yes, I'm here. So by chance then, I picked the one person who wasn't here. What do you reckon? You know what that is? That's dad powers, that is. Okay, so let's look at pop. So question number 1.
I mean, that's what I think of the jokes, by the way.
That's awesome. Yeah, I literally picked on the one person, Josh, who isn't here. So what are the odds? I must have known it. Like I say, it's the power of the dad. Now, pop. 2 types of subroutines. What are the 2 types of subroutines?
Procedure and function.
Where was I? Yeah, so procedure and function. In this case, for pop, if I'm popping something off the stack, does that need to be a procedure or does that need to be a function?
Function.
Completely agree with you, right? Because it's going to return it. And so let's come back to our little diagram we've got here. Currently, the pointer, what's it pointing at? Is it pointing at what we want to actually, let me write let me do it bit by bit. Let me do a bit of decomposition. Static, what's it going to return? What data type?
The string.
Thank you, Shazab. Shazab, genuinely, we've missed having you here, right? Your contributions, as always, you sound miserable when you're saying it, but it is a pleasure having you as part of the lesson.
I kind of just looked at the time and woke up late.
Well, I think it's really important we keep to these things, though, because I had the year 12s, so current year 13s, year 12s last year, and, I really insisted on keeping to timings because, we want it, like, when you come back to school, you want it to be as easy as possible, and it's so easy to get into the habit of, like, going to sleep later, waking up later, you know what I mean? And that's just going to make it 10 times harder when you come back, so... anyway... Okay, so now let's look at my little iPad. Where are we? Here we go. So here's the iPad. Is the pointer pointing at the thing we want to remove?
No.
No. So what's the first thing are we going to have to do with that pointer?
-1.
Right. So we're going to have to go pointer equals pointer -1. Let me switch. Nope. Yes. So pointer equals pointer -1. Wicked. So now the pointer is pointing at the right thing. It's pointing at Bobina. Beautiful name. That's totally fine, James. What I'm suggesting then is I put this assignment on here is that you could then, if you've done it in your book, you could take a photo, and then I've not seen this done yet, but it must be possible to then, in the assignment, because it's a Word document, is just stick your image into the Word document. Anyway, pointer equals pointer is -1. So now it's pointing to Bobina. It's a wonderful name. What do we do now? What do we want to do with Bobina? Guys, you are literally here leaving me hanging. What are we doing with Bobina? We're popping it. Go on, Ian.
We want to pop it. We need to pop it
off.
Yeah, so this needs to come off. So what the hell does that mean? Well, that means that we need to return... What's the name of our data structure?
String.
What's the name of our data structure? That's a data type. What's the name of our data structure that we're using to hold it all?
Array.
What's the name of our data structure? Array is a type of data structure.
Oh, stack.
What is the name of our data structure? Stack is a type of dynamic data structure. What is
static.
Name?
Static.
Static is a type of data structure. It's a classification of data structure. What is the name of our data structure?
The function.
Guys, what we said about this ages ago at the beginning of the lesson, we were looking at... Oh, sorry, actually, it's on this slide here, the previous slide. We said the idea here is that in the center, there's an abstract data type means that you have these operations like pop and push, and then there's the complexity is hidden inside. So the actual physical and logical operations to achieve pop and push. That's what we're doing right now. We're saying that we're creating a stack, but inside the stack, it's actually being held in a
Physical
Variable.
operation.
Yeah, but what data structure are we using to hold our stack?
Operations.
Oh my god, guys, what the hell is
Array.
that?
An array.
Right, and what is the name of the array?
Names.
Hallelujah. So names. So return names at what position?
Pointer -1.
Pointer -1. Right, who thinks that's a good idea?
No, because you just move the pointer down. You're not actually removing it.
So let's remember where we were. So here's where we were. First thing we did is we moved the pointer down to point at Bobina. And then we're saying returning the thing. What is at... So this is where the pointer is. What is it pointing at pointer -1?
He's pointing at Bob.
Right. Do we want to remove Bob?
No, we
No.
don't.
So do we do -1?
No.
No.
No. There you go. Beautiful. And then this is popped off. This is returned. Now, will it actually move? Will it actually be removed, the data? Physically,
No.
it's staying in the array. But remember, we talked about this. Now, because this is gone, this has been popped off. Physically, it's still there. But next time you add something in, where's it going to get pushed?
You've written over it.
Exactly. Thank you, Shazay. That's exactly what's going to happen. So we imagine that's happened logically. So shall we test it out? So let's pop. And then let's print contents again. And then I will run this. What are we seeing? So first of all, oh, there you go. Well, that's worked well, isn't it? Because we've got Bob, Bobina. No. Bob, Bobina. No. But of course it will do that because we've popped it off. We've returned it. But we've not actually set it to get rid of it. So I suppose logically we do need to do that as well. And then so we probably also need to go... it depends how you wanted to do this. I don't think this is strictly necessary. Like, for instance, if we then said pop and then we pushed... I don't know. John Connor. We put that on there. When we run it this time, we'll see that John, do you see, got overwritten over Bobina? Anyway. Also, when we popped it off, what did we do with that data? We didn't do anything, right? It's just a stack.
No.
It popped it and it didn't go anywhere. So probably one.
There's allocated to free space.
Yeah. Well, what we probably want to do is if we popped it off, is to do something with it. Hang on, how we could say something like this: the new, the item removed from the stack is plus pop. What's that going to do? So it's going to say the item removed is, and then pop, it's going to return the string from that pointer and it will attach it to our sentence. Oh, probably put space in there. But you see that? The item removed from the stack is Bobina, because the deal about a subroutine that's a function is that it's returning that data back to us. So we've returned a string, and now we've actually used it here for doing our message. All right. The next two items we need to do is full and is empty. Okay? And if we've done is full, we'll then have to use that in which one? Push or pop?
Push.
Exactly. You'll need to test to see, is it full? Is full, is that going to be a procedure or a function?
Function.
Right? Because it's going to have to return what? What data type?
It has to return the value.
True.
Well, a billion.
Boolean.
Boolean.
Right? And what about is empty? Procedure or function?
That's also going to be Boolean.
Function.
And it's also going to return
Function.
a... I think you said...
Boolean.
Yeah, there you go. Yeah. People, guess what I want you to do now?
Write the code.
Write the code to attempt to do the code for is full, and then use that for push. So the first thing should happen here, it should be something along the lines of if is full. Yes? And you'll have to test if it's full. And if it's full, you shouldn't add the item. Else, so you could say even something like if exclamation mark. Do you know what the exclamation mark is in this?
Not.
Not, yeah. So if it's not full, then you can add the item. That's the sort of thing you might be looking to have to do. I'll get rid of that for a second, but that's how you make use of it. My suggestion would be implement is full. How are you going to determine if it's full, by the way? Let's think about it logically.
Just the pointer pointing at null.
Well, not even at null necessarily. Do you know the length? Do you know the size of our array?
Yes,
No, I
it's
don't
10.
know. What was it?
It's 10.
Yeah, indeed.
All right.
And you could even go names.length. What's that going to return back to you?
The length
Yeah.
of the arrow.
Well, that's
Of
not happy
stack.
with me. Oh, because I'm not storing it. I'm not doing anything with it. Is that the issue? Not a statement. Yeah. So if that, I'm going to delete this in a second, right? So if pointer has something to do, it's not actually necessarily equals, because if you think about it, if there's right, how big? Like, look at my example here. How big is my? What will length return for this one, for this array, for this stack? What?
6.
Sorry. What length for my stack? You're seeing is the picture here underneath me. What size will that
Yeah.
return? Go on.
Isn't that 6?
6 exactly. If the pointer is here, right?
Pointing at 5.
Yeah, if it's pointing at 5, you're right. So it won't be. It will never get to 6, but it will be, you know, at
Minus
5.
1.
Yeah, and if it's pointing to 5, it must mean, because remember, the pointer points. Which one does it do? Does it point to the first free position?
Yeah.
It does. So here, right now, it's saying that the pointer is pointing to here. As soon as you put in Bobina, it actually will point to what?
6.
6. So it actually, that is the check, isn't it? If the pointer is pointing to the length size of it, then it is full. It's actually a piece of cake, to be honest. I mean, it's easy for me to say, I know, but... And then don't go into is empty, then use that to do the is full bit. Guys, how long do you reckon you...
Wait. So if your point's at 6, the 6 is there, but there's no actual free space.
Yeah, well, if you think about it, here's what happens. Let's go through the mechanism of what happens. So Bobina... So the first thing that happens, right, is that the pointer is at 0.0, correct? Let me just make the iPad big. So the pointer is pointing at 0.0. We've initialized our stack, correct? And we've got these values here we want to push onto it. First thing that's going to happen is that Bob is pushed onto the stack at position of the pointer. Pointer increases by 1. Yeah?
Yeah.
Then Bobina gets pushed onto the stack. Pointer goes up to 2. So you see eventually you'll have a value where you'll be at 4. Pointer will be at 5. Yes? Bob will get pushed onto the stack. Pointer will go up to here. And then you can't put anything else on. And so the pointer will say it's pointing at position 6. Is there a position 6?
No.
No. So the test is pointer equal to the length of the array? And if so, that means it's full.
Oh, right.
Make sense?
Yeah.
Wicked. Saeed, when did you turn up? You know I take a register, Saeed, right? So I recorded it as being no ages ago. We miss you. We'd like you to be here. Okay, maybe he's not actually there either. Mother of God. Anyway, I want you guys to implement then is full by using the concept of a pointer that we just talked about, and then inside your push, then you should use an if statement that checks if it's full, and if it's full, it shouldn't push something on. You can maybe give a message saying like it's full, and then you can try and do the same thing as empty. Think about a pointer, guys. Here's how I want you to do the assessment, the assignment. In fact, I'm going to just turn my camera off for a sec so I can show you. I really want to make sure that people get the grade and they get the reported what they've actually done, rather than just sit on a call and not do anything. So if you look on what I've shared now, under assignments, you'll see that stack Java code is there, and then you'll be able to click on there. I can see a bunch of people who have viewed it. If I go on Ian, what he's got is he's got the code, right, that I've pasted. It doesn't include pop, so you could extend the pop bit. Then, in NetBeans or whatever, do the code for is full and is empty, and then paste it in here for me to see. All right, guys? So I want you to code in NetBeans or in a online editor, your choice, totally up to you. But then when you submit your work, I want you to put it in there, and then I'm going to mark that. And I'm going to use that to determine whether you were actually in the lesson or not. Because clearly, if you haven't put anything in there, it means you weren't really in the lesson. What James was talking about is he was doing it on paper, which I completely understand. Hopefully, there's a way, though, if you wanted to take a photograph and insert it, like insert picture. Oh, and if you've done it on your camera, you can probably go from this device, because you've just taken the picture. If you take the picture on that and then stick it on that way, James, so that should work. Okay. Any other questions before I leave you to get on with that?
No.
Okay, fantastic, guys. So that'll be the last time I talk to you, obviously, on this Thursday. Remember, we said it was fortnightly, but this Thursday you have a lesson. Next Thursday you won't.
Your mic.
So this Thursday we have a lesson. I put it on your calendar, so you'll see which one you've got it. And then, what was I going to say? Yeah, so I'll call off now. But in the background, you need to be working on, as in between now and Thursday, you need to be working on making sure you finish off that implementation. And I really, in all honesty, I hope that shouldn't take you that long. But if it does, fine. But if you do blitz through it quickly, please go onto Coding Bat and get your exercise in that way as well. Remember, we need to. How do I put this? The current year 13s will have some kind of adjusted experience. I don't know how adjusted your experience will be. It might be that your year 13 is going to be 100% of the same expectation, which means that this year we need to get coding done, which means that we need to start our programming project in term 4, which is not that far off. And doing the project, clearly it requires you to learn how to properly program. So we need to, if we go easy right now, if I'm go easy on you right now and I'm not putting high expectations on you, I'm being cruel to you, because in the end you'll be in a situation where you'll need to do these things. So the harder we work now, the easier your life will be in the long run, and your life is in the long term. So please make sure you make the effort. Get this bit done with the stack implementation. But be honest with yourself. If you found it easy, or you know what you're doing, do some coding exercises. This is all about you. This is investing in you. All right, mini lecture over, guys. I'll look forward to looking at results by this Thursday. Make sure you've put it there. You don't even need to submit. You can just do it, and in live I see the work happening. So if I go to Teams, I can see you doing things as it goes along. So just make sure you put it in there. If you've got any questions, you write them in, and then I need to start setting up for my next lesson, because I'm going to use my green screen for that. So yeah, if you've got any problems, send me a message, and I'll get back to you. Okay, guys?
Okay.
All right, people.
Okay,
Pleasure seeing you guys, as always.
Thank you, sir.
Thanks.
Bye,
Bye.
sir.
Bye.
Take it easy, people.